ScanCAD International presentation on Inspection and Data Creation Tool for the stencil and screen fabrication industry. The ScanSTENCIL product is the leading stencil inspection product in the world, used by both stencil and screen fabricators and users. A combination of PowerPoint slides and actual ScanCAD software will be utilized during this video presentation. I think most of you will agree that inspection and process control means no surprises. Typically, in a manufacturing facility, a surprise is a bad thing, so the more surprises can be avoided, the better. The first part of this video will briefly discuss ScanCAD International, the company, and why stencil screen inspection and data creation is now necessary. The second part of the video will describe the two different stencil inspection products available from ScanCAD International, an entry-level product and a full-function product. ScanCAD International has been providing solutions to the electronics industry since it was founded in 1990. ScanCAD products have actually been around since 1987 when they were being offered by a European company that was later purchased by ScanCAD. Currently, ScanCAD has an install base of over 900 companies in 42 countries. Systems are sold and supported both directly by ScanCAD and under a variety of private labels by several OEM partners. ScanCAD systems are all PC-based, low-cost, easy-to-use systems. These systems are also multi-purpose with many applications that can be run on a single system by simply adding additional software modules. ScanCAD systems are designed to simplify the complex technology that is present in today's manufacturing environment. One of the main reasons inspection is needed is to keep your current customers happy by shipping quality stencils every time. Nothing is worse than losing a good customer to a competitor because a defective stencil was shipped. A single bad aperture on a single stencil can cause extraordinary problems and costs for a stencil user. In some actual situations, the price has even been millions of dollars. Another reason for stencil inspection and data creation is to help win new customers with a guarantee of quality stencils every time and the capability to create or modify Gerber data to exactly match a PCB. How can stencil inspection and data creation help to keep your existing customers and win new customers? By providing a solution for customers that require 100% automatic optical inspection of all apertures for their business versus antiquated manual inspection. A conformity certificate is shipped with each stencil to document this 100% inspection. Check for CAD errors and fabrication errors by inspecting both the cut file and the original customer Gerber against the actual stencil. An image of every shipped stencil can also be archived for future reference. Inspect partial and half-etch features as well as complete apertures. Inspect photo tools used for emulsion screens or chem-etch stencils. Inspect the mandrel for electroform stencils. Eliminate manual visual inspection, which is subject to operator error, and also eliminate the cost, chemicals, and time associated with producing the films for visual inspection. These savings can be significant and supports environmental concerns. Finally, the system also creates Gerber data from calibrated scanned images of PCBs, artwork, stencils, or even drawings when no data exists. Easily modify this Gerber data to exactly match a PCB, minimizing solder paste defects. Now you may ask, how is this done? ScanSTENCIL, a powerful inspection, measurement, process control, and data creation tool. The ScanSTENCIL system is a table-based system with a high-resolution scanning system located on a shelf below the table surface, so the scanner surface is flush with the tabletop. This allows for scanning very large objects such as stencils and frames. The system is very versatile with top or bottom lighting, color or black and white imaging. It is an accurate system utilizing a NIST-certified glass calibration plate for traceability. Programming of the systems can be done either by CAD, Gerber, or Golden Part. ScanSTENCIL can provide 100% automatic inspection of stencils and emulsion screens for size, shape, area, location, and presence-absence of apertures. The resolution of the system is sufficient to inspect very small features. The system is in use today in production facilities inspecting apertures as small as 50 microns, or 2 mils. Presence-absence inspection of prototype parts with feature sizes down to 10 microns has also been done successfully. Guarantee your stencil and screen quality. Compare stencils to actual PCBs to minimize potential solder paste issues. Create the required Gerber data when none exists from scanned images of boards, artwork, or stencils. There are 2 versions of ScanSTENCIL products available. ScanSTENCIL for both inspection and data creation, and if your budget does not allow for the low-cost ScanSTENCIL system at this time, an even lower-cost system is available. ScanSTENCIL Lite for inspection only. ScanSTENCIL Lite can be easily upgraded to the full ScanSTENCIL product at any time by simply purchasing an additional software module. Why use ScanSTENCIL? ScanSTENCIL is the leading stencil and emulsion screen inspection system in the world since its release 10 years ago. Most major stencil manufacturers are using the system, and in fact, one stencil fabricator has 14 systems in their facilities around the world. Ensure a quality stencil or screen with 100% automatic inspection of all apertures and features. ScanSTENCIL and ScanSTENCIL Lite are the lowest cost stencil and screen inspection systems available in the market today. They also have a very low annual maintenance cost, including software warranty. The systems are very powerful and can inspect apertures down to 2 mils or 50 microns. As mentioned, even smaller aperture sizes are possible with presence-absence inspection. Why use ScanSTENCIL? This actual stencil demonstrates the power of ScanSTENCIL. The images from upper left to lower right are progressively zoomed-in images of one of 118 errors found on a wafer bump stencil that has approximately 400,000 small apertures. The green color is the Gerber data positioned over the blue color that is the actual stencil. The error crosses show the exact location of each of the 118 missing or incorrectly sized apertures. 100% automatic inspection of 400,000 apertures in less than 10 minutes. Clearly, a powerful tool. Some additional reasons to use ScanSTENCIL are the ability to inspect stencils or screens of virtually any type of material, including metal, plastic, paper, etc. Even inspect partial or half-etch features with color imaging. Inspect PCBs, fixtures, tooling, and virtually any flat part. Verify that the stencil matches the PCB for the customer before production. One system can be used for both inspection and data creation. ScanSTENCIL is PC-based, so it's fast and easy to use. Stencil inspection can be performed in 6 quick and easy steps. First, import the Gerber data or CAD data. Next, scan the part to be inspected. Then automatically align the scanned image to the Gerber data. Perform an automatic inspection with the required tolerance. The operator can then view any defects, zooming in and out if necessary. Each defect is clearly numbered and presented in sequence. Ideally, there are no errors, so then a certification report can be printed for shipment with the stencil. Now, let's see the ScanSTENCIL system in action.
So to do that, what we'll do is we'll go ahead and shift now from the PowerPoint presentation over to the ScanSTENCIL software. This is the main menu screen, and as mentioned, there are those 6 easy steps to inspect a stencil. The first being to import the Gerber file. When you import the Gerber file, you will see the image on the screen in the green color. I'll zoom in here so you can see that well. Once the Gerber file is imported, the next step is to scan the image. So you simply step down through the scanning function and scan the image. No different than how you use a normal scanner that you might use in your facility today. When you scan the image, the resulting image is a blue image. So I'll zoom in now so you see the results of the scan. What the system does at this point is we overlay the green Gerber data on the blue scan image, and now you can see we have the stencil ready for inspection on the screen. At this point, there is a check mark on the left side, and you simply answer the questions It'll automatically detect what inspection level is needed for this, because obviously with smaller apertures a tighter inspection level is needed. And the system now performs an inspection. For this particular stencil there are 66 errors. We can zoom in close to see what has happened here, and we can see in this situation we have some Gerber data where there is no hole in the aperture, for whether this was a data creation problem or actual problem in fabrication. So we can see we have two situations here of missing apertures on the stencil. Lower left corner indicates that there are 66 errors, and you simply hit N for the next, P for the previous. So we can actually move sequentially through these errors and find the next error. We see here, again, we have a missing or blocked aperture on a stencil. In this case, in a BGA. Now, the next error shows a couple incorrect size apertures. In this case, the stencil opening is much larger than requested in the Gerber data, in the CAD data. And then finally, in this example, for this particular stencil, we show a shifted image. So in this particular situation, this device has actually been shifted to the left, and again, that is certainly not a good thing to have in a stencil. So you can see how easy this system is to work once there is an inspection, and certainly let's assume that it's a good stencil. At that point you would print the conformity certificate, pack it with the stencil, and ship that to a customer. In the case of a stencil user, you could print on the left hand side here, this icon, print the conformity report and indicate that this stencil is ready for manufacturing. Let's take a second now and look at some other samples while we're in the software, just to give you an idea of the magnitude and power of the system. Thought I'd bring up in the system right now the wafer stencil that was shown just a minute ago in the PowerPoint presentation, again to show the power of the system. This again has the green Gerber data and the blue scan data. In fact, just to help this process a little bit, I'm going to zoom in a little bit so you can see just how powerful this system is. I'll just index in just a little bit so you can start seeing that there is the green data over the blue scanned image. Now, just as before, we could use this particular inspection function. However, in this case, we're going to use a different inspection function here that is designed for these types of very, very small apertures. If you look in the very left corner here, lower left corner, you'll see from time to time some numbers there. There are actually 340,000, over 340,000 apertures on this stencil being inspected for this video right in front of you. So it's counting down. It's now already down to 100,000 apertures. It's counted down now to 50,000, down to 10,000, and now we have these errors. Again, the PowerPoint mentioned 118 errors. There's actually only 117 on this stencil. Now I'm going to zoom in real close now so you can see what this looks like. As you can see right here, we have a missing aperture, If I zoom out a little bit, we can see the wafer bump stencil. I will now index to the next error and yet to the next error. These can be looked at by zooming in very close or out. Here we have an underformed aperture, so you can see there's just a small opening there. Certainly not proper for this stencil. If I zoom all the way out, or as I zoom out here, you will see the 117 errors as X's. So this is giving you an idea of the power of this system. By the way, if I look at the aperture table, I will zoom up here real quick and show you this. There are 342,606 apertures that are 3.7 mil. So 3.7 mil on this stencil, and there's one aperture that happens to be 12 mil. So that was the inspection for this stencil. Let me quit now, and let's take a look at another sample image for you. We have a step etch sample here, or some people might call this half etch. What we'll do here is I'll run the same type of inspection, and we'll go ahead and run this, and we have these errors here. Now I'm going to turn off the Gerber data so you can see this. This stencil, since we are inspecting half etch features, is scanned in color instead of black and white. If you'll notice a minute ago, the other stencils appeared as blue images. In this case, it's a color image. Zooming in a bit, you can see the half-etch feature here. Zooming out a bit, we can see the two errors. Here there were to be 2 additional fiducials on the stencil that are missing. So this is simply communicating the ScanSTENCIL is able to inspect half-etch features as well as features that are etched all the way through. I will now step to another image for you. The system not only inspects solder paste stencils or stencils used in glue or adhesive, but it also works for emulsion screens, because this system, as mentioned in the PowerPoint, is both color and black and white, can utilize both back and front lighting, either top or bottom lighting. So the image I'm loading for you right now is a emulsion screen. If I zoom in a bit, you can see on the image the screen image. And if we go ahead now and perform an inspection, because there are both tracks and pads on this, I'm clicking a different button here, and we'll look at it for errors of 1.5 mil or 38 micron or larger and perform the inspection. Again, lower left corner, we can see the system is processing this image right now in front of you. While it processes, I'll comment that under the Gerber comparison check, there are 3 different forms of inspection. The LMA for pads, tracks and pads, and no LMA. This is what permits this system to look at incredibly small apertures. Now we do have an error here on the emulsion screen. Again, they're numbered from 1 to 17 in this case, so we can sequentially step through these. If there's any time that you want to zoom in on a particular image, you can zoom in and see what the error is. Again, the green is the Gerber data, and you can see in this case we have a color image here. So we can see that there's some missing emulsion here between 2 traces that is a potential error. If I single step through, we have some missing emulsion here, and we even have some foreign debris here, or a hair, if you will. Oh, I should comment, by the way, in the case of this video, that the quality of the video that you're watching here will not be nearly the quality that we're looking at here on the system. Obviously, for purposes of creating this video, the quality, we need to reduce the quality to keep the file size down. Okay, at this point, let's now move back to the PowerPoint presentation. 1 second, please, as we move forward.
As you will soon see, the ScanSTENCIL system can also create or screen Gerber data as well as the inspection that you just saw. This data can be created from a scanned image of a bare PCB as well as a stencil or screen, artwork, or even a paper drawing. The software contains 99 layers, so the stencil can be compared to the bare PCB or even multiple PCBs, or a variety of revisions of the same PCB as well as the Gerber data. Also, compare the stencil to either the original customer Gerber or to the modified cut file. Errors can be introduced to a stencil from many sources. If the stencil does not match the PCB, the ScanSTENCIL system can be used to correct the problem and modify the Gerber to match. Potentially, this can be a new service and source of additional revenue. Why adjust the stencil to match the PCB? To minimize solder defects during the SMT assembly process. As many of you know, actual PCBs can have stretch and shrinkage of up to several mils relative to the design Gerber data. And so they may not match the stencil, especially with today's fine-pitch devices. A recent SMT magazine article describes an actual case study where solder defects were reduced by up to 43% by modifying the stencil Gerber data to match the actual PCB. 43%. Use ScanSTENCIL to create a stencil that matches the PCB. Let's now see how easy this is using ScanSTENCIL.
Okay, again, we'll move from the PowerPoint presentation over to the ScanSTENCIL product. In this case, let's go ahead and take a look at an actual board. This board has been scanned in color. We'll go ahead and zoom in a bit so you can see this. So we have a color image of the PCB. The system is able to color separate or extract out the pad information. And this is put in the blue data here, as you see. upper left corner, you'll notice something called Vectorize. And then we have the ability now to go ahead and create apertures, actually create Gerber data for this board. If I zoom in now, I'll turn off the color image. We can zoom in and see this purple information. And what we can do is we can merge that data into this layer here. And we now have Gerber data for this board. If I snap to this pad, lower bottom here, we can see that this is D187. It's a rectangle, 56 by 28 mil. There's 14 of these pads. If I snap to this pad here, we can see this. Again, I can have the benefit of the Gerber data laid on top of the color image. I'll click this on and off so you can see this. So that is how easy it is to make Gerber data to match a board. Also, I should share here very quickly that you can also edit the Gerber data. We, for example, could go ahead and delete a pad. We could go ahead and grab onto a pad, and we can move that pad, shift it up, down, left, or right. You could add additional pads. The system is a full editing capability with the benefit of a calibrated color image of a board or of a stencil in the background. I'll go ahead and exit out of this example, and let's step into a more complex example. In this case, we have scanned a stencil, and again, stencils are scanned in black and white, so we can see the stencil image here is the blue image on the screen. There is no Gerber data present. In this case, we will now go ahead and vectorize this and create Gerber data automatically, just with one button here, for all of these apertures. It created pads for 2,647 apertures, again, in the same technique you just saw on the color board. I can go ahead and move this data into the system so we can see it now as green Gerber data on the screen. I can snap to each of these pads. This data can then be output. In fact, I will go ahead and share that with you right now. We'll go ahead and output this data as Gerber 274X. So here's the Gerber 274X. This is the output format needed to move to a stencil house for fabrication. So that is creating Gerber data or modifying Gerber data using the ScanSTENCIL system. We will now step back to the PowerPoint presentation. 1 second, please.
Okay, so in summary, ScanSTENCIL inspection, process control, and data creation tools can be used to maintain excellent customer satisfaction by shipping good stencils and screens, avoid stencil and screen problems which can cause significant rework and scrap, create or modify Gerber data as needed, and reduce the stress within your organization by eliminating surprises. Please contact ScanCAD directly or talk to your local sales representative for more information on ScanCAD products. Several other products not mentioned in this video are also available from ScanCAD. Some of these products are legacy re-engineering of PCBs, bare board flying probe testers, pre-production process setup systems for inspection and programming for the SMT assembly market, inline conveyorized or offline desktop automated inspection systems for functions such as solder paste inspection, adhesive inspection, ball placement inspection, hybrid print inspection, wire bond inspection, or skip mark detection. Inspection systems for other products outside of the electronics industry such as fuel cells, photovoltaics, photochemical machining, and others. Software tools for minimizing EMI during the design phase of PCBs. Please see our website for more detail. This concludes our presentation. Thank you for your time and attention.